Okay, we can start. Good morning, everybody. My name is Vittorio Zaccaria, and I'm associate professor here at Politecnico di Milano. And it is my great pleasure to welcome you, together with Paolo Bonzini, to the KVM Forum 2025. And on behalf of our entire academic community, I extend our warmest greetings to actually to this great forum, to this prestigious forum and this gathering here. Allow me briefly to introduce the institution that hosts this forum today. Politecnico di Milano was born in 1863, so more than 160 years ago. And today stands as a public university, which is recognized globally as a center of excellence in engineering, architecture, and design. And in particular, your forum, this forum, is very important to the Department of Electronics, Information, and Bioengineering, where all the computer science and engineering teaching and research happens. And in this specific domain, as you can see, we are particularly proud of to be ranked among the first in Italy, the 8th in Europe, and 53rd place globally. So each year, actually, we graduate more than 500, engineers, essentially computer science engineers, many of whom will undoubtedly benefit from the technologies that you are going to discuss here today. KVM and QIMO at Politecnico di Milano. So why does it matter? Okay, what is the actual intersection between the two? Well, essentially, these technologies are crucial for our missions. As a users, KVM and QIMO provide to the students the ability to create consistent, reproducible environments where they can actually experiment with operating system concepts and without the fear to damage any hardware. And this is very transformative for our educational approach. In particular, in courses like the Advanced Operating System course and all the security-related courses, these tools allow to really explore kernel modifications, test security configuration, and understand system architecture in ways that would be impossible with traditional approaches. As developers, since we are actually forming, we are graduating developers, in our courses we take rigorous, theoretical and practical approaches. We start from the Popek and Goldberg theorem about virtualization and guide students through the advanced topics in modern virtualization, virtual ballooning, kernel same page merging, and so on. So our students just don't learn about these technologies, but they also, play with them. This is very important for us because it allows us to create engineers that are on the edge of the technology. And finally, as researchers, we are, working on virtualization, especially in the field of embedded systems like the automotive and the aerospace mixed criticality domain. So, to end my very short introduction, as you begin your technical sessions and presentation, remember that your work, extends far beyond, code repositories and performance benchmarks, but in our case enables education and research. So I wish you productive discussions here, innovative insights, and meaningful collaborations. And again, welcome to Politecnico di Milano, welcome to the KVM Forum, and benvenuti in Milano. Thank you very much. Thank you, Paolo.
So thanks, welcome from me as well. I'm invited Professor Zaccaria also because a few years ago he asked me to give lectures in his course about KVM, and it was like really nice to see students learning again from theory to KVM, VFIO, and all the stuff that we talked about here. So I'm happy to be here at Politecnico. And before starting with my usual KVM status update, I'm going to, first of all, thank all the sponsors and the university for the patronage and the Conservancy for helping with the organization as usual. This year we have a huge amount of sponsors, and sponsors are super important to guarantee that KVM Forum stays healthy and to help with the organization not only of this KVM Forum but also of next year's KVM Forum. So thanks very much to all the sponsors and to all the people that traveled, whether they are sponsors, speakers, or attendees. Some quick logistics information. We have 2 rooms. This is one of the 2 presentation rooms. The other is on the opposite side of where you registered, so on that area. Here in the court, somewhere there will be coffee breaks, and you will obviously see them. For the lunch, you are on your own, but there is a map with ideas of places that were carefully vetted. And tonight we have a dinner also inside the university. It will be near what is called Building 14, but basically it's also on the lunch map, and you can reach it. If you go to your hotel, you can reach it from the street, from Via Bonardi. Otherwise, if you instead stay here all the time inside the university, for example, for BOFs or whatever, there is an underpass, so you don't have to go out to the street. The Wi-Fi password was sent to you via Eventbrite. If you didn't get it, check the spam folders as usual. It will be shown on screen during the breaks, and there's 2 different ways that you can log in. One is with Politecnico credentials. That's the wrong one. You have to pick the second option, which is with a person ID. We have authorization for 1,000 devices, which should be enough. Okay. And that's it, basically. If you have any question, you can ask. Usually there will be someone in the smaller room, and we will try to answer you. And now I'm going to start with the status report for the last year, which already starts with a mistake, of course, because it's not June. Like, June is more or less the date of the last release, but now it's September. We are at 617 RC4, and we had about 1,900 commits, which I will briefly refer them as 3 shons. Like, that's the unit of measure of patch contributions to KVM. Compared to 2 years ago, we are basically 50% above what we were. And the ratio of stable patches is going down, which I personally see as a good thing, because it means that we have fewer bugs that need to be fixed in stable releases. The ratio of self-test patches also went down. We used to have 300, which was 30%. This year we have 200, which is a bit less than 10%. That's probably something to be expected, because a couple years ago there was a lot of development in the testing infrastructure. But still, self-tests are important, and recently we also documented what kind of testing we expect contribution to come with. So keep adding tests so that we don't have regressions and we don't have stable patches. I didn't do the usual slides with the graphs. I just did a small summary of the statistics. Of course, among the architectures, we have ARM and x86 that see a lot of development, whereas RISC-V, LongArc, and S390 and Power are a bit less active. With respect to authorship of patches, Google is firmly #1. But this year, especially ARM and Intel were very close in numbers for number 2. And then there's everybody else, Red Hat, IBM, Longson, ARM, AMD, Ventana. So you can see that basically with the exception of Google and Red Hat, it's basically hardware vendors that contribute to KVM, which I suppose is expected. A lot of development work came from the architecture maintainers, and in particular, Mark and Oliver together had a very respectable 0.6 Shons. And I mean, in case you didn't know, unit of measures are always with a lower case initial, so that's... there were a lot of changes also to generic code last year. I think one of them that is really worth pointing out is reworking the reference counting of pages, making KVM use page numbers instead of struct pages. This is important because it both fixes bugs and makes the code simpler. The bugs fixes were especially important for GPU assignment. It was something that was requested especially by Chrome OS people, so they should be happy now. There were some simplifications to the code. One thing that I would like to have more is moving code from architecture to common code. In particular, one small but significant change was to have common functions in generic code to lock all the vCPUs. And there were also a lot of documentation cleanups. I think there were also some conversions to restructured text, some reorganization of directories in the documentation, and so on. Going to the architectures, this is something that I think is relevant for ARM. One work that has been going on for several years is everything that is needed to do cross implementation, VM migration. So to migrate from one ARM implementation to another. All the feature and implementation tracking was redone using code that is generated automatically from JSON data that is published by ARM. So that's a nice solution. Nested virtualization got a lot of changes towards basically almost finishing the project. Like nested virtualization and KVM in general is never finished, but it can be called useful and usable, and there will be a talk by Mark later. In particular, there's support for nested virtualization of address translation instruction, virtualizing the VGIG, and PMU support. Virtualizing the VGIG means that you can use the processor interrupt virtualization capabilities also for the nested VMs. Other highlights were transparent use pages for PKVM, some of the extensions that were implemented. One of them is guest permission indirection, guest permission overlays. Support for hibernation, PSCI call. Very recent one from 6.17 is the Geek v5, and many more, but these were like the highlights. For IS5, they finally added access and dirty bits to the specification, and KVM supports it. Dirty memory tracking supports now both bitmaps and the ring buffer-based tracking. And also there's been some initial work on nested virtualization. So I will have something to say about nested virtualization next year as well, but for another architecture. S390, a lot of the changes actually were not beneficial for the virtual machines themselves, but more for the development. In particular, the page fault handling for S390 was always very different from everyone else, and also because of the folio work, there were a lot of cleanup moving the page fault handling to the KVM directory. It used to be part of generic S390 memory management code. A lot of cleanups where some fields were used only by KVM in special ways for the primary MMU page table entries, and this is also cleaned up. I think S390 is not yet using the normal MMU notifier infrastructure, but I think that's also in the works. And another thing is you control self-tests. This is important not just because of the self-test, but also because of kind of the principle. U-control is basically a hardware testing feature that is used inside IBM for testing the processors and for testing Linux. And there was no public code that used this feature. Now it's possible to test it under the self-testing environment. And this is something that we also made a policy that we allow, in some cases, features that are not implemented by neither QEMU, CrossVM, or anyone else that is open source. But in this case, we really want to have tests and coverage for these features so that people can both learn how to use it and also make sure that it doesn't break. For x86, the absolute highlight is probably TDX hostile support, which took literally years. And you can see why, because even before we committed the TDX patches, we had a lot of related work just in the last year. Some of the strange behavior that KVM implemented was moved to Quirk, so you can disable it not just for TDX, but also for normal VMs if you want. Virtualization used to be enabled on the first VM that was started. Now it's enabled when KVM is loaded. This is also what enabled some of the cleanups that I mentioned earlier. And also, it was made possible by the fact that, for example, there is a KVM backend for VirtualBox, so there is a lot less need compared to a few years ago to have virtualization enabled on demand. And over the last year, we also got some discussions from VMware people about using KVM in VMware workstation. And an important outcome was also that we convinced VMware people to, for example, do some things differently for KVM and follow more the KVM architecture and contribute to KVM if they can, instead of just trying to reuse the code that they had for their proprietary hypervisor and using it with KVM. There were cleanups and improvements everywhere for hypercall, VM destruction, order. Guest state protected is handled better than it used to be. And TDX was really massive, but it was an improvement not just for the TDX code itself, but over the years, I'm really happy with what we got in the end. There were some optimizations, especially around TLB and memory management, less TLB flashes especially, and batched TLB flashes, less lock contention, and also because now we have the MMU that is specifically developed for two-dimensional pages, so EPT and MPT, we can dynamically allocate the shadow MMU data structures because they are now used only for nested virtualization. We have a nice couple of processor features for AMD processor. Idle halt reduces the number of VM exits, which is a nice optimization. And also we were able to separate IPI virtualization from posted interrupts. And this is also important because some AMD processors had an errata that prevented using the virtualized interrupt controller. And now instead we can isolate the part that had the erratum, and we can have the optimization of interrupts at least on one side, at least on the sending side, which is nice. Sorry, on the receiving side. And finally, for a lot of the patches the 1900 patches that we had this year, there were an incredible amount of cleanups in x86 code, a lot of old code, like literally like 10, 15 years code. KVM is like being 20 like next year or or more or less. But there was code that was almost as old as that and has been cleaned. There was a huge cleanup from Sean about posted interrupts for both Intel AMD. We got some requests to improve the way that K-threads are tracked, and we applied it to the non-executable page recovery. Also, rewritten CPU ID handling, improved K-config so that you can choose better what to enable, what to disable. Some sharing of code between KVM and non-KVM code, because the posted interrupt feature now is available also for MSIs. A lot of nice things that improve the code and prepared us for the next year of development. Finally, GasMemFD was introduced for confidential computing, so for SEV, SMP, and for TDX. But there's lots of changes planned for the next releases. In particular, we recently got support for mmap of the GasMemFD, which allows using it also for non-confidential VMs. We got NUMA support, and in-place conversion between private and shared is not yet committed, but is on the way. And basically that's it. There will be 2 talks after me, so one here and one there. So there's plenty of time, about 5 minutes to get out of here and there and get into the other room for those that want to follow the other talk. Thank you very much.